pi over 2 pi, pi over 2.
What? So today we're going to learn about the graph of tangent. Tangent, as you will see, has a period of just pi rather than 2 pi because tangent of x equals tangent of x plus pi. Here we see the graph, and tangent goes in periods of pi, negative 3 pi over 2, negative pi over 2, negative pi over 2 to pi over 2. And you can see the asymptotes every 180 degrees. And here it reaches the origin because at 0 degrees, right here, 0 pi, tangent equals 0. While at 90 degrees and 180 degrees and so on, and 270 degrees, and every 180 degrees after that, it will equal, it is undefined because it is 1 over 0. Here we have the graphs of cosecant and secant. First we'll start off with cosecant being the inverse of sine. The easiest way to do this graph is draw the normal sine graph, starting at the origin and going up, hitting the x-axis again, going down. And then from there you find the maximums and minimums and also the nodes. And at the nodes you will draw a vertical asymptote that the graph will not cross. And then at the maximums you draw up with the graphs hitting right here at this point. And then same with the minimums, just do it the opposite direction going down. And that's easy for cosecant because it's the sine graph. Same as for the secant graph, which is the opposite of, or the inverse, or the reciprocal of cosine. You draw the normal cosine graph starting at 1 at the y-axis, going down to the axis and then down and back up. And then from there you find your nodal points right here and here, and you draw your asymptotes as you can see here. And then from there you find the minimums and the maximums, and from the minimums again you draw the a without a cross part right there, and from the maximums you draw the u. And it follows the same rules as sine when you're worrying about parent functions and transformations.
Let's do a problem. Y equals 2 tangent x plus 1. Here we have our a value. Our b value is equal to 1, and this is our y coordinate transformation. If we were to graph this function, this plus 1 right here tells us that the parent function will be moved up 1, and this affects the stretch of the function. However, we can neglect this during tangent functions. So, if we were to move the coordinate up 1 from 0, 0, we have our y-intercept. Now, a tangent function has a period of every pi. That means that the function repeats itself every pi. Since the b value is 1, we know that for this function, the period will also be pi. And since the center of the function is at the y-intercept, we go over pi over 2 and negative pi over 2. Now, all we have to do is draw in the vertical asymptotes and sketch the function. Here we can see how the function repeats itself every pi. Pi over 2 plus pi equals 3 pi over 2, and negative pi over 2 minus pi equals negative 3 pi over 2. The vertical asymptotes repeat themselves, and the function starts over.
Trig functions of angles are used to find ratios, while trig functions of ratios are used to find angles. Now, if we get f of x equals sine of x, the whole thing is a ratio, while x is the angle. And if we get f of x equals inverse sine x, then the ratio is x, and the angle is a whole function. Now, inverse sine of x has a principal value of range of negative pi over 2 to pi over 2. while cosine or inverse cosine has a power of 0 to pi. And tangent is also the same as inverse sine, where with the range of negative pi over 2 to pi over 2.
Take, for example, the problem f of 1/2, where f of x equals arcsine. So what this is telling us is that the ratio that comes out of the angle is going to be 1/2. So in this problem, we are going to be finding the angle. Now, if you were to look back at the unit circle, you would notice that the only times where 1/2 occurs is during pi over 6 or pi over 3 and their multiples. However, since we are working with the sign here, we can rule out pi over 3. Since pi over 3, the 1/2 is in the x-coordinate, while the root 3 over 2 is in the y-coordinate. And we are finding the y-coordinate. So, root 3 or pi over 3 will not work, but pi over 6 will satisfy this function. So here we have a very similar problem. However, the input this time is negative 1/2. So, we know that since we are working with sine, that the y value must equal negative 1/2. So it's going to look a little something like this. Negative 1/2, root 3 over 2, and this angle here must be pi over 6, as we found out with the previous problem. Now, on the unit circle, we could just say that the answer is negative pi over 6. However, if we were asked to express our answer in terms of 0 to 2 pi, we would have to find another way of expressing negative pi over 6. So, we know that this right here is either 0 or it could also equal 2 pi. And if we were to go down negative pi over 6, we would get the same ratio here. However, to figure out what negative pi over 6 equals, we're going to take 2 pi minus pi over 6. Get common denominators, 12 pi over 6 minus pi over 6. And you get that the answer to the problem is 11 pi over 6.
When measuring angles in practical situations, you only have two types: angles of elevation and angles of depression. If you want to measure the angle from here to up there, you're measuring the angle of elevation. When measuring from here to down there, we're measuring the angle of depression. In case you were confused by my past instruction, this is a better example of this. This is the angle of elevation, and this is the angle of depression. So in this problem, we have an angle of depression of 7 degrees in a lighthouse 750 degrees from the surface of the water. 750 degrees below the surface of the water. Let me draw this. And our variable is right here with x. So because we don't know x, and we do know our angle right here, we're looking at 150 over x, and we know this is opposite over adjacent, and we know our SOHCAHTOA. I'll write this out. Oops. Opposite over adjacent, 150 over x equals the tangent of 7 degrees. So from here, we can choose our calculators and solve. And we can figure out that x equals 121.
So, have you ever wondered, if I were to be sitting on top of a trash can, and you wanted to know the distance from you to a certain point on the ground, how would you do that? Well, I'm about to show you. As you can see, I am on a trash can that is approximately 4 feet tall, and over there we have Skylar, who is on the ground. So,
If we were to draw an invisible line right where Skylar is, it would be 4 feet tall. And to the bottom of that line, we would have an angle of about 35 degrees. From that point, we can use the tangent function and use opposite over adjacent to solve how far away I am from Skylar.
Now, the same principles can be applied for how much taller I am than Lexi.
These are watermelons.
Carrots
Frozen.
Carrots